Hello. So we are continuing with our chapter Laws of Motion in Physics for Standard 9th. We had seen up till now the different types of forces in the first part of the chapter. In the second part of the chapter, we saw the first law of motion, which was related to inertia, and which also told us about the qualitative nature of the force, that how or what is force and what kind of physical quantity is force and what it can do. In the second law of motion, we found out the quantitative nature of the force, means how much amount of force is going to be required for a particular body to move or to come to rest. So these were the two things what we learned up till now about force. But we had not understood up till now that how does a force act on a body. Okay, so the question of how does a force act on a body is answered by the third law of motion, and that is the Newton's third law which we are going to learn now. So we can see that Newton's third law of motion, Newton's first law tells us that to bring a change in the state of rest or in the state of motion of an object, a force is needed. That is, a force produces a change in velocity of the object. Okay, I just told you that. Newton's second law tells us the magnitude of the acceleration produced by the force when applied on the object. These two laws do not explain how does the force act on the object. This question is answered by Newton's third law, which is stated as follows. According to Newton's third law, okay, it's a very easy law. So according to Newton's third law of motion, to every action there is an equal and opposite reaction. So to every action there is an equal and opposite reaction is the third law of motion. Every action, equal and opposite reaction. So there's so many examples of this. Like for example, if I am going to run and hit this particular wall directly, what is going to happen? Is the wall going to break? No, it's not going to break at all. But in turn, what is going to happen? I am going to bounce on the other side. I am going to hit and go on the other side. Why would that be? Because the force which I have applied on the wall, the same force is applied by the wall on me. And that is the reason every action, that is my action of hitting the wall, there is an equal and opposite reaction from the wall to me, and hence I fall down on the other side of my motion. I don't fall on that side unless until this thing breaks off. Okay, even if this breaks off, there will be a force which will be acting on me, right? When I am pushing something, something also pushes me. So that's the reason you need to continue. Like for example, when you are pushing something, at that time you need to keep a grip on your feet. Otherwise what will happen? You tend to slide backwards. Yeah, it's nothing but the action and reaction of the third law. So that is, considering the examples which are given over here, consider a book lying on a table. The weight of the book acts vertically downwards, but the book does not move down. See, when I hold this duster down like this, does my hand move down? No, it doesn't move down. Why? Because I am giving an equal force from the bottom to hold this thing over here. So to the action there is an equal and opposite reaction. Action was downwards, the reaction is upwards. So action reaction will always be there for any force which is applied. Any force will always have the two components, that is action. Against that action there will be a reaction. It implies that the resultant force on the book is zero, which is possible only if the table exerts an equal upward force on the book equal to the weight of the book. This force on the book balances the weight of the book. So the book जो है, या तो duster की बात करेंगे तो duster is acting a force downwards. I'm making it, there will be, my hand is going to give an upward force. So accordingly the duster will be at equilibrium because the downward force is equal to the upward force. It will remain stationary. So instead of my hand, we can always take a table, because hand, of course, I am in my control. I can do whatever I want, but the table, it's just a non-living thing. So when I'm putting anything heavy on the table, what happens to the table? No, if it is strong enough, it will not break, but it will just remain over there. So the object is going to remain on the table, right? Secondly, while moving on the ground, we exert a force by our feet to push the ground backwards, the ground exerts a force of the same magnitude on our feet forward, which makes us move forward. Now this is very, very, very important to understand. We are able to walk, we are able to run. All these, our movement is because of the third law of motion. It is the third law of motion which tells us that there is action reaction. So what is going to happen? So now suppose we are walking. While walking, what is going to happen? We are pushing the force backwards. When I am walking, what happens? I am pushing the floor backwards. So I am pushing it backwards. So the floor gives a reaction to give me go forward. So that's why I go further, then I go further, then I go further, and that's why we are able to walk. Now you may feel, "Arey nahi, aisa nahi hota," but just imagine one thing. What will happen when you are trying to walk on an oily surface or your feet is landing on a banana skin? What is happening? At that time, the force which you are trying to act, that particular force doesn't act because there is no friction. Because there is no friction, that's why what is going to happen? Your force is sliding down, and that's why you are not able to, the floor is not able to push you back because that layer, that particular floor is slippery. That's why it is no force which is acting directly on the floor. We are not able to apply the force on a slippery surface because there is no friction. Right, so this is how you can see that when we apply a force by our feet on the ground is going to give you an opposite force which is going to make you push forward. That is what exactly the runners do. What does the runner do? They grip on that particular, that mark over there, you know, when they run, and then they push forward. And why do we have the grippers on the shoe? Because so that you can grip the ground, and then you means that the studs or the spikes which are there on the shoes of the footballer or a cricketer or even the athlete, why do they have that gripper? So that they get a complete grip with the floor, so that they do not slide down, and whatever force they are applying on the ground, equal and opposite force is given on them so that they can run faster. Right, so this is how the third law of motion is giving you that particular push for the action which you have given on the floor. So you give an action on the floor, and there is an equal and opposite reaction on your body, hence makes you run faster. So we have got some explanation over here regarding this thing. So it is, in the above stated example, we observe that there are two objects and two forces. In the first example, the weight of the book acting on the table downwards is the force of action, and the force exerted by the table on the book upwards is the force of reaction. Yes. So if we have this particular table over here, this is a table. Okay, this is a table, and a book is lying over here. So the book, W of the book is acting over here, which is the downward force, and a reaction force, that is the reaction from on the table, is going to act upwards. This is the reaction force. So this is called as the action force. The action is the weight of the body. The weight of the body is action, and the reactive force, that is the reaction force, which is given by the table. In the second example, the force exerted by our feet on the ground is the force of action, and the force exerted by the ground on the feet is the force of reaction. Thus, Newton's third law motion states, in an interaction of two bodies A and B, the magnitude of reaction, that is force from A to B, applied by the body B on the body A, is equal to the magnitude of action, that is force B to A, applied by a body A on the body B, but they are in opposite direction to each other. Of course, you don't need to learn this particular definition of the law of motion. It is better to use the every action is equal and opposite reaction. But you can understand this thing better, that it is given over here, when two bodies, this body A and this body B, A is the book and B is the table. So the amount of the force which is being acted by the book on the table, that is the action force, that is A to B, and the amount of reaction force, which is the table acting the force on the book, is the reaction force. They are always equal, and their direction is opposite to each other. Okay, they are opposite to each other. right? So the action and reaction never acts on the same body, but they always act simultaneously on two different bodies. That is, the force of reaction always present in a pair. So you can see it's present in a pair. So action is on one body, reaction is on another body, and that is why they do not cancel out. मैंने इधर ठोकर मारी तो मैं इधर गिरा. It never cancelled out. It did not happen that just stick over here. I got stuck over here. No, it did not happen that way. Why? Because the action was on the wall, and you get confused because when I say that I am applying a force of 1 Newton from here and you are applying a force of 1 Newton from here, and we say that because both the forces are same, so it cancels out and this body is in equilibrium. Yet it is not so. Why? Because in the case when I give a force here and you give a force here, the body on which the force is applied is single. It is single body. This body is one body. Okay, they are not two different bodies. The different forces are acting on the same body. But in the action reaction, the action is on the palm and the reaction is on the duster. So automatically, because both of them are on separate bodies, no doubt they are equal and opposite in nature. The direction is opposite and the magnitude is equal. But since they are acting on two different bodies, they do not cancel out each other. And that's why the reaction is there. Otherwise, we would have never been able to walk. Because my force and the force given by the floor is the same, and if that is going to be on the same body, it is not going to cancel out. So then the body will not be able to walk at all. Right? But we are able to walk. Why? Because when I apply a force on the road applies the force on me. That's why the reaction and action are not on the same body. They are on different bodies. That's why they not cancel out. Okay? Right. So now to do this thing, we have got an experiment which can prove this thing. So what they have done is that they have taken a spring balance. You know spring balance? वो घर में जो रद्दी वाला आता है तो he has got the balance जिसके ऊपर से पकड़ के रखते हैं तो यहाँ पे there is a marking that okay 10 kgs 20 kgs and so on. So you are going to take two such spring balances. So the spring balance, the photograph is given over here in the book. This is the two spring balances, and what they have done, they have hooked up over here and connected one of the spring balance over here. Another spring balance is connected here, so it is like this, one spring balance here, another spring balance is over here. So one is connected to the wall and another one is we are going to hold the thing. So, and then when you pull it, so when you are pulling it, you are actually pulling only one spring balance. Right? So what should be the resultant be? The resultant should be that one of the spring balance should give you some reading of 10 Newton or means whatever kg you are applied the force into. And this should not give you anything at all because there is no kind of a force acted by the wall. See, because one spring balance is connected to the wall. So the wall is going to pull it, and here this one you are going to pull it. So it is like this. It is, and you are pulling it. So one is connected to the wall, this is connected to you. And when you are pulling it, so when you are pulling it, one of them, this side should only give the result because that is the one on which you are applying the force. So this should have no effect at all. But you will find that when you pull this thing, the reading over here and the reading over here is the same. Why is it same? Because it proves that whatever is action force given by you to pull it over here, there is a reaction force to pull this towards itself by the wall. So this action and reaction is always equal and opposite in nature. That's why this is showing the same reading. This is in this side towards the wall. This is towards you. So that is how you can see that the action and reaction forces are proved by this experiment. So we have over here that experiment, the ring of the spring balance is attached to the hook fixed in the wall, and then the hook of another spring balance A is attached to the hook of the spring balance B. Now the spring of the spring balance A is pulled. We find that both the balances show the same result. Explanation: the spring of the balance A pulls the spring of balance B, due to which we get some reading in balance B. The same reading is seen in balance A because the spring of balance B also pulls the spring of balance A by the same force. You can see that if A is pulling B, B also pulling A. So it's always the same thing, and that is why it is the pull of the spring B by the spring A is the action force. Okay, B by A is the action force and A by B is the reaction force. So this demonstrates that to every action there is an equal and opposite reaction. So if the magnitude of FAB is equal to magnitude of FBA, but they are in opposite direction, or direction FAB is minus FBA. So we have got some examples now about the different these law of motion. One is the book on a table. So yes, when a book is placed on a table, the book exerts a force equal to the weight W on the table in the direction AB downwards, and the table balances it by an equal force called the reaction force, R is equal to W, acting upwards on the book in direction AD. So that's why this shows that action and reaction. This is we had done earlier also. So let's go to the next one. Pushing a wall. When you exert a force on a wall by pushing the palms of your hand against it, you experience the force exerted by the wall on your palm. I told you, if I hit the wall like this, I'm going to push it is going to push me on this side. So action is my hitting the wall, and the reaction is the wall hitting me. So that thing is going to be there with the wall and you. So action, reaction force. Motion of the boat moving away from the shore. So when a boatman wants to move the boat away from the shore, he pushes the shore by a bamboo or by his oar. The shore pushes the boatman along with the boat away with an equal and opposite force. So you must have seen that many times the people who are the fishermen and all, or even when you go to maybe you go to Essel World, so you are going to take a ferry for going from the Gorai Creek to the Essel World. So what is going to happen when you are going to enter into that, or sorry, so when you are on that boat, so what happens when he wants to start the boat? He wants to go a bit away from the shore. So for that, what they do, take a bamboo sheet and they push the shore. When they push the shore, the boat moves on this side. Or they even take the oar and push the shore to move it this way. Why is that so? Because when you push the shore pushes you, and accordingly, because you are on the boat slides away from the shore. So this is quite a common thing what we are seeing in our day-to-day life. Another thing is motion of the boat in water. To move the boat ahead in the water, the boatman pushes the water backwards with his oar, and the water exerts an equal opposite force in the forward direction, due to which the boat moves ahead. So when you are rowing, what happens? You are rowing it this way. So what is going to happen? The row is when you are rowing it. So you are putting the row here in the water and then pushing the row here. And what happens? You go forward. You are pushing the water backwards. You are going forward. You are pushing it this way. Even when swimming, in the same thing. When you are swimming, what is going to happen? If you are giving a freestyle, then you are putting like this and you are pushing the water down backwards. You are pushing the water backwards. You are pushed forwards. Right. Similar, so when you have or even you have a breaststroke, though you are going here and you are pushing the water backwards and you are going forward. You are pushing the backwards, you are going forward. So what is happening? Your action is a backward force towards the water, and the water gives you a forward force to move ahead. So this is how the motion of the boat or motion of the human being or anybody swimming takes place. Next is firing a bullet from a gun. So when a man fires a bullet from a gun, a force F is exerted on the bullet and the gun experiences an equal recoil. Now you must have seen that when you hit a gun, you get a big of a, even with an air gun, your small air gun which you take that balloon ka फोड़ने का वगैरह रहता, तो it is not going to be so simple that okay click किया और हाथ में कुछ झटका भी नहीं लगा. Every time you shoot, you are going to have a short recoil. In fact, those who have done shooting, they will be knowing that they will always tell you to put it in a position so that the recoil doesn't harm you. So there is going to be a recoil of the rifles and the recoil of the gun when they are shot. So that's the reason they put it very stable. We put that particular gun in a stable condition so that it does not recoil and you are hitting bang on the target, because when you are hitting it, if it recoils, you are definitely going to miss your target. So that's going to be a recoil. So the recoil is nothing but, so when the bullet is being hit, there is a recoil. So this bullet is hit, so bullet gives a recoil. So that's why the gun is going to have a recoil. The motion of the rocket. The rocket also moves in the principle of the third law of motion. What is going to happen? A huge amount of fuel is being burned and the gases are being thrown on the ground. So when the huge amount of gases are thrown on the ground, that gases are exerting a action force on the ground, and that action force on the ground is being given a reaction force such that the rocket flies off. So the movement of the rocket is also due to the third law of motion. So you can see in a rocket, fuel is burned inside the rocket and the burned gas are at high pressure and high temperature are expelled out of the rocket through a nozzle. The rocket exerts a force F on the gases to expel them through a nozzle backwards. The outside gases exert an equal and opposite force on the rocket, due to which it moves in the forward direction. So in this way, the rocket is going to move in this manner, where in the action and reaction forces. Okay, we have another examples. One sec. Yeah, so we can see about the rocket. So rocket is going to expel out a good amount of gases through the nozzle, and the gases which are going to be hitting the outside gas is going to push the rocket upwards. The next is motion of the man on the ground. Yeah, again the same thing. When a man applies the force F, action backwards by his foot on the ground against the force of friction, the ground exerts an equal and opposite reaction forward on his foot. So on that action of the foot on the ground, there is a reaction force which is going to make the body move forward. So action and reaction is going to be there. The horizontal component of the force of reaction enables a man to move forward. Obviously, it is difficult for a man to move on a slippery road where friction is less. So it is basically the friction force which is exerting over there. The friction के हिसाब से the force is being able to, because of the friction, he is able to apply the force on the ground. See, if the friction is not there, his feet is going to slip down. When he is slipping down, he is not able to apply the force on the ground, and that's why there would not be any equal and opposite reaction. So at that time, friction is the most important, and that is the reason if you have anything which is a slippery floor, you are not able to walk properly, because you are able to not apply a proper force on the ground. So that exactly what I give you the example about the oily surface, or the surface which has got a banana skin on top of it or something like that. So in all these cases, it is going to be difficult for us to walk. The next is motion of a boat away from the shore while stepping out down from it. Now you must have experienced this also, that when you are trying to get down from the boat, okay, you are in a boat and you are trying to get down from the boat. What is going to happen? As soon as you put your one foot forward and you try to put the other foot from the boat to outside, the boat tends to go backwards. So that's why you will always find that the boatman will keep the boat, he will hold the boat till the time you are not getting down. Why? Because when you are going to get down, the boat is going to move backwards. Why? Because when you are trying to go forward, you are giving a backward force on the ground, which is nothing but the boat. So boat will not be stable. Boat being in the water will tend to go backwards. So instead of it giving you a force going forward, it will go itself, it will go backwards, and accordingly there will be a possibility that you may tumble off. So that's the reason they will always keep the boat tight together, or they will anchor it or do something so that the boat is not moving when you are trying to get down from the boat. So that's why it is that when a man exerts a force action on the boat, its force of reaction enables him to step out of the boat. At the same instance, the boat tends to leave the shore due to the force exerted by the man. So when you are trying to go out, you are exerting a force on the boat. The boat automatically is actually should be giving a force on you. Yeah, it does do it, but at the same time here the boat also moves, because boat is something not in a stable surface. Finally, catching a ball. While catching a ball, the ball exerts a force on the hand of the cricketer, and the cricketer exerts an equal force on the ball to stop it. So when you are catching the ball, the ball is going to hit you and the hand, and that's why there will be a reaction force to make it go upwards, but you normally catch it. So what you are doing is you are catching it so that you are giving an equal force for it not to bounce back. So that's why equal and opposite reaction force is there. So your hand is going to give a reaction force. It is going to see to it that the ball is stopped by the person. So that's why you will have an equal and opposite reaction. From the ball will be the action, and your hand catching the ball or stopping the ball is the reaction. So that was about the third law of motion, a very simple law, and even the examples over here are very simple. So it's easy to understand also and easy to write the answers for give reason also. As I told you earlier also, whenever there is any kind of a give reason stating about any of the examples of the laws of motion, remember that there should be at least one line in your answer stating that which is the law that particular example is dependent on. Like for example, if they say that motion of a rocket, then you have to say over there, it is very much compulsory that even in the start or in the end you should say according to the third law of motion. Do mention these lines because they are very important, or you can say the keywords for required for that particular answer. We have got only two numericals over here, very easy numericals. There are hardly anything to understand in this thing. So let's go through that also very quickly. Numerical 1, a boy pushes the wall with a force of 10 Newton. So the first one is the force pushed by the man is 10 Newton. The boy is giving a force of 10 Newton on the ball in the direction which is east. Okay, it is giving the force of 10 Newton in the east direction. What force is exerted by the wall on the boy? Of course, so it will be, this is the action, right? So the reaction force, reaction is equals to 10 Newton east. So ये क्या होगा? West. That's it. That's simple. Nothing. No calculations. Nothing. Action, reaction are just opposite to each other. Magnitude remains the same. So this is just this much. You may write over here according to the third law of motion, but I doubt if they would ask you such silly questions. Anyway, this is asked, so it's better that you understand this. Second one, a block of weight 50 newtons hanging on the rigid support of a string. What force is exerted by? Block on the string. So the block on string is equals to weight of block. So that will be, what is the weight of the block? Is 15 Newton. So it is 15 Newton downwards. We know that it is downward because this is the block. It is like this. This is a block which is acting the downwards. So the block on the string will be downward thing, which will be a string, which will be equal to the W. So that will be 15 Newton downwards. That is nothing but the weight of the block. And string on the block. The string is going to apply on the block. So that's why an opposite force over here, string on the block, that is nothing but the tension. Okay, tension on the string. That is a string on the block. That is, this is the A part. B will be string on block is equals to reaction force, which will be equal to 15 Newton. Now this was downwards, so this will be upwards. Okay, so that's the thing, and this will be, of course, this is nothing but the tension on the string. The tension on the string. This is the tension on the string. Okay, so this gives you the very easily the third law of motion. So we studied the third law of motion. That was every action has an equal and opposite reaction. Okay, in the next video we'll take up the fourth law, or we can say the gravitational law or universal law of gravity, and along with that we'll be having the 20 numericals which are there. So we'll take up the numericals along with that. Okay, so that was laws of motion, third law of motion.